Electrophoretic technology mimics the effect of ink on paper. The screens reflect light, unlike conventional backlit displays that emit light. Also known as e-paper, this technology has changed the way we see our screens. Mobile devices, e-readers, smartwatches, and credit cards all contain electrophoretic displays. With its print-like readability and Bluetooth capability, it's easy to see the attraction. To make an electrophoretic screen, polyethylene film is placed on a sheet of glass, which holds the film as it's processed. Production takes place in a filtered room to keep the area contaminant-free. Inside the room, robots move the glass carrier through processes that transform the film into the backplane. The backplane is the main structure of the screen. It carries the organic transistors that drive the electrophoretic display. Machinery builds up micro-thin layers of metal, organic solutions, semiconductors, and isolators. This spin coater evenly spreads the material across the film. Nozzles apply an organic solution that acts as a booster for the semiconductors. The spin coater closes and rotates the glass carrier to spread the deposited material by centrifugal force. The automated system adds layers of semiconductors, electrical isolators, and metal. A rinse of deionized water cleans the coated film, and a blast of air blows off the water. Rollers apply gentle pressure to ensure the film sticks to the glass, even when positioned vertically. Once the photoresist chemical has been applied, the film goes into an exposure chamber. A pattern mask is placed in front of the film to block out lighting in some areas. The exposure defines the structure of the metal layers, so that when combined with the other materials, they'll serve as transistors. The backplane film is removed from the glass carrier. Now the film is ready for the electronic ink sheet placement. A technician places the backplane in a laminator. He uses a camera to magnify and position the backplane. A vacuum in the laminator chuck pulls the backplane in place. He places the electronic ink sheet on the chuck beside the backplane and peels off the liner, exposing the adhesive. Then the ink sheet and the backplane are fused together. A roller presses the assembly for full adhesion. Once the lamination process is complete, a technician removes the screen from the chuck. This is the backplane before and after the electronic ink lamination. An automated system bonds the electronics to a circuit board that's attached to the display screen. The system mechanically seals the circuit board. Polymer resin is applied for stability. UV light cures the resin. This is the electrophoretic display before and after the electronics have been added. This particular display screen will be an e-reader. They load a graphic with black strips onto the screen. The strips serve as reference points as a printer applies a combination red, green, and blue filter. The filter adds the option of colored text or pictures. The primary colors can be combined to create other shades, expanding the visual possibilities of the electronic ink. A machine bends a sample screen repeatedly to confirm that the sample is flexible enough to be formed into a bracelet or credit card. Additional tests are conducted to confirm that the electrophoretic display has the desired clarity and color. Display patterns can be sent from a phone to a bracelet that has an electrophoretic screen. With electrophoretic technology, There are many different ways to enjoy screen time. A dry erase board is a non-permanent surface most commonly used in professional or classroom environments. You simply write on the board with a dry erase marker and use a specialized cloth to wipe away the markings. These effective tools are an easy way to get your message across. Dry erase boards are also known as whiteboards. The boards wipe perfectly clean due to its non-porous surface and the dry erase ink. Dry erase ink contains release agents, which prevent the pigments from permanently adhering to the surface. Green and black dry erase boards can also be used as chalkboards, while gray and low-gloss white double as projection boards. The surface material is a porcelain-coated steel sheet, flexible enough to be rolled up but also pressure-sensitive. To start, the roll is mounted on a cutting machine. A technician programs the machine to cut the roll to a specific length based on the board's dimensions. Workers verify the length and check that the piece is square. The surface material will be applied to one of 7 types of substrate, ranging from cardboard to medium-density fiberboard known as MDF. The next step is to cut the large sheet of substrate, in this case MDF, into board-sized pieces. Another technician enters the length and width into the cutting machine. Once complete, the machine ejects the substrate, which is now cut to the exact size of the board. Next, the substrate is put through a hot glue machine. The machine applies polyurethane adhesive to what will be the back of the dry erase board. As the substrate exits, a sheet of foil is applied to the glued surface. The foil prevents moisture from entering, which would warp the substrate. The board moves through 2 steel rollers which flatten the foil and press out any trapped air. Next, the surface material is applied to the other side of the substrate. A craftswoman uses an air hose to clear away any dust from the side of the board. Once cleaned, the board goes through the glue machine. The porcelain steel sheet is placed on the glued surface. Technicians work carefully to ensure they don't touch the pressure-sensitive surface with their fingers. Then the board moves through the steel rollers to press the porcelain steel flat and remove any trapped air. Once 50 boards are stacked, technicians put them in a press for half an hour until the glue cures. In another part of the factory, a machine cuts material to create the board's frame. It punches V-shaped notches in the length of aluminum trim. The trim bends at each notch to form a wraparound frame. Some boards come with a marker tray that runs along the bottom. To make these trays, a technician cuts board-length pieces from a piece of L-shaped metal trim. Since the tray ends are sharp, a technician attaches plastic covers for protection. He secures the plastic end covers with screws on both ends of the part. Meanwhile, technicians peel off the protective film covering the writing surface. Then they flip over the board to assemble the parts from the back. This model doesn't have the traditional wraparound frame. Instead, it has a frame comprised of 4 straight C-shaped pieces that fit over the board's edges. To add stability, technicians attach screws through the trim into the substrate. Once assembly is complete, the dry erase board is placed into a box, ready to be shipped to a business or classroom near you.